what you're going to learn in this talk is, first of all, what's Cloud HSM and why would you use it? And then I'll talk a little bit about some of the new Cloud HSM features that we're announcing today as well. And then afterwards, Matt will come on stage and and explain to you about customer managed encryption keys and explain how it works and how you leverage customer managed encryption keys to help meet your compliance requirements. Now, at the end of this talk, I can pretty much guarantee that you'll learn something new, at least one thing. And my only ask of you is that you please do not fall asleep. These are really, really comfortable chairs, and we need you to pay attention. Okay. So forgive me if this is going through some of the things that you may already know, but I always find it's useful to kind of level set and talk about, what are the options that we have available today. So we have a wide spectrum of different ways to do encryption of your data at rest in our Google Cloud. And so by default, we encrypt everything. And if you've ever talked to me before, I'll tell you that we're not going to give you a choice. You have to encrypt your data at rest, and there's no option to turn it off. Google was the first cloud to do this, where it just became an automatic thing. And if you do nothing, then we will make sure that it's encrypted at least one layer, and we'll do all the key management and everything else inside internally through our own internal KMS system. Now, you can also use Cloud KMS, which we introduced a few years back, to actually go and create your own keys. And with those keys, you can support something called customer managed encryption keys. And what that allows you to do is that it allows you to leverage the data at rest, but protect that data at rest using a key that's under your control in Cloud KMS. Okay? And because of the work that we did with Cloud HSM, you can use both Cloud KMS and Cloud HSM keys synonymously. Okay, so you can actually use this to actually protect data with your keys in Cloud HSM. And then finally, we have customer supplied encryption keys. So this is something that we provide for support of both GCE and GCS. And what this feature does is that when you go and try to access your data, you have to provide a secret along with your API call. Okay, and so we don't persist that secret, which is necessary to unlock the data. And so for that reason, if you don't access the data, it's really, really, really hard for us to actually get access to anything. Now, the one thing that I just want to point out about that is that it's only available for GCS and GCE. And a good reason for this is that we really don't have access to that key otherwise. And so if we don't have access to the key, we can't do things that are offline, like compaction or logical backups or anything like that. So it'll only be for those two services. Now, what's an HSM? How many people here use an HSM? Okay, good. Actually, I would say over half of you. So for the other half, an HSM is a hardware security module. It's basically a physical device that's used for managing and performing crypto operations. Okay. Now, there's a lot of reasons why people use these. You can create keys that are non-exportable, and the hardware device will provide certain guarantees to prevent the keys from being exported or exposed. And they often provide some guarantees around tamper evidence and tamper resistance. So things like if you try to extract the key, it'll be something that you'll be made aware of, and in the extreme cases, they can potentially zero out the keys as well, so that the attacker can't actually get access to anything. And the final thing there is that they're often Fips 140-2 certified. Fips 140-2 is a certification from NIST that basically defines crypto modules, and so it covers everything from the implementation of the algorithms to the way the random numbers are generated and everything else. Most times, people are using these devices because they either are very heavily regulated, and so these things are often helpful in getting through your compliance auditor, or they're required to protect high-value keys. So financial institutions, for example, are very, very big on these things. Now, what we've done with Cloud HSM is that we provide the managed service on top of these devices. So for the other half who have actually had HSMs, you know that they can be a little bit challenging sometimes to actually manage. And so we have taken that burden and we manage everything to the point where all you see is an API to do the key management and do key generation, encryption, decryption, things like that, right? And so there's really nothing for you to do. We actually manage it and we fully scale it, right? We do auto patching, we do the backups of the keys, everything. So there's nothing for you to do. Now, one of the things that you might be asking is that why would I use our Cloud HSM? Well, compliance is, again, a major motivator for this. We are using HSMs that are Fips 14-2 level 3 certified, right? And so that may or may not be important. If you don't know what that means, then you probably, this doesn't matter to you. But if you do care, then you know that level 3 is sort of the gold standard that everyone looks for now. And you can only achieve level 3 through hardware devices. You can't do this with software. Regionalization. So one of the interesting properties of the service that we've created is that when you create a key in our Cloud HSM service, that key is cryptographically bound to the HSMs within that region. So if you create a key in, say, US Central 1, then only those HSMs in US Central 1 are able to actually go and use those keys and perform crypto operations. Okay, it's just that there's a strong binding cryptographically between the keys and the devices themselves. We will eventually support a global region, and we're working on multi-regions right now. But currently, we have this deployed in several regions across the United States and Europe. And for those people who are already using Cloud KMS, then there's actually no changes necessary. It's the same API. It's just one flag when you actually create the key, and then everything else is exactly the same. I should have mentioned earlier that if you need to ask any questions, please feel free. I have a little bit of a hard time seeing because it's so bright, but just wave your arms wildly and I'll probably see you. Okay, great. Now, I want to make a couple announcements. One is that Cloud HSM is generally available. It was actually generally available, a few months ago, but in case you didn't know, it's GA now. So if the GA label is important for you, then you have it right now. And more importantly, we have the Singapore region live. So today we have it available in 3 regions across the United States, 2 in Europe, and now we have 1 in Asia. And we're rapidly increasing the number of data centers that we will be supporting. And you should see in the near future that we'll be covered almost everywhere that you expect cloud to be. Okay. Oh, and one more thing. I'd like to also announce that key import is now available in alpha. Okay, so with this, you'll now be able to, at least for the alpha, to import your symmetric keys into our Cloud HSM. Okay, and it'll be done in a very secure manner where you will not have to worry about the keys being exposed. Now, in the beta, we'll expand this to support other types of keys and import into the software. But for now, you can actually import this into the HSMs. And the way that works is that we use a method called, well, it's a PKCS11 method. So just forgive me for a brief moment where I step into a little bit more technical jargon. But we're using the RSA Aes Key Wrap. And essentially, the way that the process works is that the HSMs will create a public-private key pair with the private key only available within the HSM, so we don't have access to it. And then you can export that public key, take it to your key management device, and then on your key management device, you would have to do this process called Aes Key Wrap. And essentially, the process says is that your key manager would have to go and create an AES key to wrap your key, or the key that you want to import. And then the public key that you just downloaded would wrap the AES key. And then you take that and bring that back up to our cloud. And then our HSMs are able to unwrap everything all within the HSM boundary.
My name is Matt Driscoll. As I said at the beginning, I'm a product manager, and I focus a lot on customer-managed encryption keys. So what is Cmac? Cmac is a feature that allows you to control the encryption keys that are used to protect your data at rest in Google Cloud. This is a really, really important feature if you need to show control for regulatory or compliance reasons over the protection of your data. We'll talk in a second in a little more detail about where this is available on GCP today, but just very quickly, it's supported in Bigquery, Compute Engine, Persistent Disk, in cloud storage, and in our DataProc product. So how does Cmac work? Actually, to understand how Cmac works, you first need to know a little bit about how encryption at rest works within Google. So Ilsung mentioned at the beginning that we provide default encryption at rest for all of your data in Google Cloud. So we'll start there. When we provide this default encryption at rest, what we do is we take data as it comes in and we split it into small chunks. Each of those chunks of data is then encrypted with a data encryption key. Then that data and its encrypted data encryption key is distributed across Google's storage infrastructure and stored. So when you come to Google and you decide that default encryption at rest is sufficient, this is generally the scheme that we use. So when you use Cmac, we're adding essentially an extra layer into this. Each chunk is still encrypted with a data encryption key, but then that data encryption key is wrapped with a KMS key. We call that KMS key the key encryption key. So what will happen when you put the data to rest is the service that is storing your data will call out to KMS. It will wrap the data encryption key with the KMS key that you've indicated, and then it will store the encrypted data encryption key and the data chunk in whatever storage system it's using. So there's some interesting properties of this that are really, really useful for compliance. The most important is auditability. So every time that we put data to rest, we actually call out to KMS, and so you can get a data access log and a log of the encrypt or decrypt of the data encryption key. And you can use that to go monitor access to your data through our key management system. Also, to the services that use KMS for Cmac, it's transparent if the key is in an HSM or if the key is in software. So all of the sort of value that you get from Cloud HSM is available with the same configuration that you would use for a software key. This is really powerful. Like, we actually totally manage, make it totally transparent to you, the customer, that we have HSMs behind the scenes protecting your data. So what are some best practices for Cmac? There's two things I want to highlight. First is regional alignment. When you actually go to configure Cmac, you'll notice that some of the services will only allow you to configure keys that are in the same region as the resource they're protecting. We push customers to do this for resiliency and for latency, and it's occasionally a place where folks stub their toe if they don't know this constraint. And the second is separation of duties. So how the services that store your data talk to KMS is through a service account. When they use that, when we provision that service account on your behalf, where we have tools to do this for you, when you create Cmac protected resources in the UI, we give that service account a very minimal set of permissions. It only can encrypt and decrypt with the KMS key. So when you're using KMS in general, we encourage you to think very deeply about what permissions are actually needed for any given principal accessing KMS and keep those permissions to a minimum. So Cmac support on Google Cloud. Today we support Cmac across 4 services, and I want to give you some detail about it. In Bigquery, we support Cmac at the table level. So anytime you create a table, you can indicate a Cmac key, and we will use that Cmac key to protect the table in Bigquery. In Dataproc, we support Cmac at the cluster level. That Cmac key is going to be used to protect the persistent disks that are in the cluster. We also allow you to indicate a storage bucket, and that storage bucket can be protected using Cmac as well. And so, implicitly, cloud storage also supports Cmac. And we support Cmac as a default key at the bucket level or as an object level Cmac key when you write an object. And finally, persistent disk supports Cmac per disk. So maybe we will move to a demo.
This is a Cloud KMS page on the Cloud Console. And when you want to create a HSM key, it's really, really simple, right? All you have to do is essentially, what did I call the key ring? I called it this. So I just want to make sure it coincides with my little script. So when you create a key ring, all you have to do is specify the key ring and then make it a region. Now, for HSM keys, you have to make it in the regions that HSM support. And for example, US West 1 is currently supported, right? So that's great. Then what you need to do is, you basically have to go down and choose what kind of key. So you can do things like, I can create an asymmetric key, for example, for signing. And when you actually do that, you get a choice of all the different types that you can have. Now, when we say symmetric key here specifically means AES 256 in GCM mode, right? But for signing, you can get to choose whatever you like. And so I'll just pick, let's say ECP 256, right? And then I go and say that I want to create this in the HSM, and then I'd say create. I have to give the key name. So, like my demo Hsm Key or something like that, right? It doesn't really matter. And then you do that, and then it goes and creates, and that's it, right? So if you ever worked with HSMs before, you know that creating a key takes a lot of steps. Here is just one flag, and now you have a key available to you. Every time you use that key, all the operations will be performed within the HSM. The key was created within the HSM, and it's ready for use with the KMS API. Now that we have that key ring and everything else, I'm going to show you how to use the key import feature that's in alpha. Now, it's in alpha. There's no UI associated with this, so you have to do it through either the API or gcloud. So I'll do it through gcloud because that's a little bit easier. So there's a couple of things I have to do to set the environment. I need to actually set an alias. It's an alpha, so you have to download a private version of gcloud, right? Just hold on a sec. Kill all that, and then let's see. I will just create that, and then just authorize it. Okay. Okay. So now we're all set up, right? And I probably need to actually go and set up. So remember I told you earlier that we're going to use a little shortcut to actually do the encryption and wrapping all within G-Cloud. And so in order to do that, you need to actually install the Python cryptography library, right? And I should have already done that here unless the reboot actually screws something up. Hopefully I'll keep my fingers crossed. If not, then I'll just have to redo this. All right. Now I create the keyring already, and so the first thing I need to do is I need to create an import job. An import job in our language is basically just an object that represents the import key, right? And so that job is basically an import key. Now this import key is going to create a private public key pair, like I said. You can download the public key, and it'll exist for 3 days. And so you can use that public key to import as many keys as you want for 3 days. Afterwards, we have to create a new one. Okay. And so if you look at the syntax here, please let me know if it's too small. It's a big screen. I think you guys are okay. So I'm creating a US West 1 under the same keyring, the next 19 demo keyring 1 I just created up there. And protection level is HSM. That's a flag that tells it that I want to create this in the HSM instead of in software. And then I specify the import method. Now, this method, there's 2 of them. There's this one, the RSA OEAP 30272 SHA-1 AES256, and there's the same one with the 4K key, okay? And so this one, I'm just going to use it with a 3K key. So hopefully that goes through. Fantastic. And then what I will do is that I'll list it out there so that we can see that the import job is available, right? And so it's there it is right there. So you can see that the demo import job is there, it's active, and the type of method it is. So we're all set now. Now the next thing we need to do is that you can actually go and also see the public key. So if you were to do this like with your HSM, you would need this public key. And so here's a PEM file. You can just copy this into a PEM, import it, and off you go. Now, what we're going to do next is that first I need to create a crypto key. And so if you're familiar with our KMS already, you have different constructs. You have that key ring you created, you have the keys, which is the container for all the different key materials, and then you have versions under each of the keys, right? And so I'm just going to create a key because I'm going to import a key version and put nothing in there. So that's all I did right here. I just created a key with nothing in there. And then I'm going to generate a symmetric key. I'm going to do it the really, really easy and quick and very, very official way, which is to use dev random. Okay, and I'm just going to get 256 bits and put them into a temporary file. And then after that, I'm going to run the import job. Now, this is where it's going to fail if the cryptography package wasn't installed for Python. But hopefully that's still there. And if you look at the command right now, it's the same thing, location, keyring. You specify the key that you're trying to import, then the target file where the actual key is, and then the import job and the algorithm, which is symmetric keys. Okay, so there we go. Okay, see, it didn't work because this stupid thing reset. Okay, so I need to go and actually do sudo pip install cryptography. And so this is probably good for everyone here to know in case you want to do this, so that you have to do this, it works. So all I'm doing is I'm installing the proper cryptographic files. The reason I need to do that is that this whole RSA Aes Key Wrap is available in this cryptography module, not in Python by itself. Whoops. Sorry, I meant to go up one more. Now I do the import job, and it should work. And there you go. It imported the key, and so you can see that it explains that it's a symmetric key, what time it's created, what project, and that it's enabled. And just to show you that this key actually works, and just remember that the key that I created is called demo import key 1. You can see it right there. I will go and do a test encryption. So, this one's really simple. Actually, I'm not going to use the txt. It's just, I'm going to create a text file that just says hello world, right? And simple as that. And then I'm going to run the standard, KMS API to KMS commands to actually do the encryption. So you can see right here, all I'm doing is that I specify that, alpha KMS encrypt, location west, keyring, everything else. And then I just give the cipher file, and it's going to export to tempct. Okay, and so if you look at tempct, you see that it's just basically gibberish, right? It's ciphertext. And now if I want to actually take tempct and I want to actually, decrypt it using that key, because it's a symmetric key, right? I use the same key for encryption and decryption. Then you'll see that it works. It says hello world. So there you go. That's all you have to do to import a key into the HSM. It's now in there. Okay. Yeah, the question is this key visible in the console? Yes, it is. So let me go back here real quickly, and let me refresh this. And so there you go. It says not available because I haven't defined what a primary key is, right? But I mean, I imported that key. It's version 1, and so you can still use it as long as you specify the version. If you want to use it just without the version, then you need to set that as the primary key. Okay. All right. Let me turn over to Matt real quick so that he can do his demo now that we got this working. So the demos are a lot more entertaining. The question is, do I have a timeline when this is going to be GA? Not exactly right now. I mean, I don't expect it to take too long to reach GA. But for now, I mean, we're looking to get some feedback from the alpha. So I encourage you to actually go and try to sign up for the alpha, test it out. And if we get enough feedback, then we'll be able to go quickly through the beta then GA process. Thank you. The question is, would this be the same process during GA, or would it be more integrated with console? Definitely, you'll have more UI with this. The way we do things typically, not always, is that in the alpha releases, we don't normally have UI support. But during the beta timeframe, we'll have full UI, full support, all that stuff. Google's definition of a beta is a little bit different than what most people really think of as a beta. Our betas are typically fully supported. And we'll have full, the things are usually locked down, everything else. Anything else? We're using a vendor named Cavium. Yes. Okay, anything else?
Perfect.
How's it going, Matt?
Good. We're all ready to go.
All right. I'll turn it over to Matt. He's got a very entertaining demo.
So for my demo, I kind of wanted to check as many Cmac boxes as possible in 10 minutes. So what we're going to do is we are going to take a public BigQuery data set that is word counts of Shakespeare's corpus. We're going to take that as the input data into a data proc job that'll re-aggregate it across and aggregate not over each work of Shakespeare, but across the entire corpus. So we'll get the word count across the entire corpus. When we do that, we will make sure that the BigQuery table it goes back into is protected by Cmac. The data proc job is going to be protected by Cmac. And all of the intermediate files in GCS will also be protected by Cmac. And for fun, we'll make sure that it's an HSM in London that's doing the protection, because British stuff. So to start, I'll show you, oh, I clicked on the wrong button. 1 second. I'm just going to show you the input data. Whoa. To start, I'm going to show you the input data with a saved BigQuery query. So I have the saved query in BigQuery, which I am going to open the query in the editor, and we'll see what the input data is. And we can see, oh wow. We can see that by each work, Hamlet, King Henry, how many words there are. So now we're going to go over to KMS, and we're going to create the Cmac keys that will protect our job. So this is a little bit of a different create path than Ilsung. So demo live. We're going to put the key in Europe West 2, which is the London region. We'll call it the key demo, and we'll make the protection level HSM. So we'll create this. Now we will go to our storage bucket. And so we're going to create a storage bucket to store the intermediate output of the job. We'll call it demo live. So now we want to protect this storage bucket with an HSM key. This is really, really easy to do. I just I put the storage bucket in the same region as my HSM key. I go to my advanced settings, and I use a customer managed key. When I go to this dropdown, I now see the demo live key that I just created. I can choose that. And what's happening here, like we talked about earlier, is I'm getting a prompt to grant access to the service account that represents this bucket. So now the GCS service account has access to that specific KMS key for encrypt and decrypt. So I'm going to create this bucket. I will go back over now to Dataproc and create a new cluster. So as before, I put in Europe West 2. I'm going to use mostly standard configuration, but then under advanced options, I'm going to choose the cloud storage bucket, demo live. And I am going to add some metadata that actually allows me to, not car, that's cat, helpers. Metadata. So I would add these into the metadata of the cluster to create the job, which I'll skip because it's a little copy-pasty. And then I'm going to choose a customer managed encryption key. So when I choose a customer managed encryption key, just like before, demo live, we'll be asked to grant access to the service account. It takes a little bit of time to spin up a Dataproc job, so I'm not going to do that live right now. Instead, I'm going to show you how this works with a job I've already created. So now what's happened is I've created a HSM key. I've created a cloud storage bucket to store the key, and I've configured that Dataproc job to actually use our HSM key. And so you'll see when I actually submit a job. Oh, and the last piece, sorry, and I'll show you this after I run it. And the last piece is in this Python script that's going to run and actually do the aggregation, I have there is a line that indicates when it creates the destination table in Bigquery to use a KMS key to also protect the destination table in Bigquery. So if I run this, and the demo gods are on my side, we should get an output. All right, so our job's running. We're coming down to the wire on time here, so hopefully it runs fast. So you see that output of the job, we're actually getting word counts out, which is great. And now we're writing to Bigquery. You can see that job's running. And the job's complete. So let's go back to Bigquery. And I'm going to look at my word count output, and I'm going to query this table. And I'm just going to select star from the output table. And just for fun, I'm going to say where word equals Matthew. See how many times I appear in Shakespeare. And did no rows? 3 times. So now what we just did is we actually read data out of BigQuery. We pulled it through a data proc job that processed the data. We wrote that output back to BigQuery and all of the intermediate data, and the output was protected by Cmac. So now to prove this to you, I'm going to go over to the cryptographic keys again, and then this key was using not demo live, demo Europe West 2, and I'm going to select this key, and I'm going to revoke everybody's permission to use this key. Oh, wait. Sorry. Show info panel. So, like we said, there were service accounts that can use this key. It has 2 members. I'm going to remove these permissions. And I'm also going to remove the permission for a key that is protecting the BigQuery dataset. And in the meantime, I'll show you that that key was cat wordcount.py. And we're going to just grep for key. So in that file, we had a destination KMS key set. That's the key that was on the BigQuery table. And so now we will try to rerun this job, and it should hopefully fail. And in the meantime, we're going to go back over to BigQuery, run this query again. Oh, give it a second for the permissions to update. All right, well, we're down to the last 30 seconds. Great. So you see permission denied on KMS key. So now, because we protected everything with KMS, we can use KMS as a way to control access to the data. So we have 47 seconds left. So that's about it for the demo. Any last minute questions? Yeah. Yeah. It is. Yep. So this could have all been, we could have used the key that Hsm created, and I would have been able to do all of the same things. So it's pretty powerful, right? Like in about 5 minutes, we just sort of created a bunch of keys in an HSM. You could import your own material if you wanted to. I can use those keys to protect both the intermediate steps and the outputs of a data processing job that spans 3 or 4 Google products, right? So this is compliance across a pretty relatively complex pipeline in a few minutes and a couple clicks. So yeah, with that, can we flip back to the presentation for 1 minute? All right, so the takeaway. So Google Cloud makes managing encryption easy for compliance-sensitive workloads. The few things we really hope you take away today are Cloud HSM allows simple and scalable access to hardware-protected keys, including importing your own key material. Cloud KMS enables easy management of all of your encryption keys, regardless of whether or not they're in an HSM. And then Cmac enables you to control encryption across some GCP services very simply to achieve your compliance goals. Thanks very much.